activity of the sample is very clearly given, 8 millicurie. What is the disintegration rate of 15 milligrams of this isotope? R equals R naught A to the power 1 by 3. Calculate maximum kinetic energy of the electrons emitted in the process. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. My conclusive session on the problems from the chapter Nuclei, where I will work out a few problems listed from the NCERT textbook. Before this, I expect you have followed the previous session. You have gone through the problems. You have tried to analyze them by yourself, due to which today's session becomes fruitful. The first one, the problem says, obtain the amount of atoms. Carefully go through that word. Obtain the amount of atoms, not the number of atoms. Amount of atoms means what? We have been asked to obtain the mass of atoms. Amount of atoms andre, it is the mass of atoms. Number of atoms is very much different from the term mass of atoms. In Cobalt 6027, the sample is Cobalt 6027, necessary to provide a radioactive source of 8 millicurie strength. So activity of the sample is given 8 millicurie, and the half-life of cobalt is 5.3 years. An interesting problem. I will have to find the mass of Cobalt 6027 that is giving me a radioactive source of 8 millicurie strength. Activity of the sample is very clearly given, 8 millicurie. And half-life of the sample is 5.3 years. Now, so activity is given 8 millicurie. But curie is not the SI unit of activity. Keep in mind, It is not the SI unit of activity. Then which is the SI unit? Becquerel disintegrations per second. So this is 8 into 10 power minus 3 milli ಇರೋದ್ರಿಂದ into 3.7. 1 Curie is 3.7 into 10 power 10 disintegrations per second. And this is 8 into 3.7 into 10 power 7 disintegrations per second. So my first step of calculation is getting the activity in terms of disintegrations per second. Now, the half-life is said to be 5.3 years. But again, I have to convert that into seconds. So this will be 5.3 into 365 into 24 into 3600. So half-life turns out to be 1.67 into 10 power 8 seconds. So activity is calculated, half-life is known. What are the other requisites now? Very good. I require decay constant. So lambda is 0.3 by T. So decay constant in terms of half-life. So 0.693 divided by 1.67 into 10 power 8. So this is nearly 4.1 into 10 power minus 9 per second. So first, I calculated activity in terms of disintegrations per second. Next, I converted half-life in terms of seconds. Now I have got the decay constant. With all these things, what is that I am aiming at? To calculate the mass of cobalt-60. So somewhere my thought says, if I have to calculate the mass, number of atoms is very important. So anywhere from this data, can I calculate the number of atoms? Come on, students, if you retrieve back. Yes, basically by the definition of activity itself. So we know activity. Yes, how do we define activity? Activity is basically defined as lambda n. So n is A divided by lambda. So substituting A, we have already got. Lambda is already here. So it is 7.15 into 10 power 16 grams. But again, very beautifully, I have got the number of atoms in this sample. So what mass of these atoms constitute this sample? Which means, now 60 grams of cobalt has Avogadro number of atoms, which is 6.023 into 10 power 23 atoms. Non-sample ಎಷ್ಟು atoms ಇದೆ? 7.15 into 10 power 16 constitutes what mass of the sample? So when you simplify, X is 60 into 7.15 into 10 power 16 divided by 6.023 10 power 23, and the answer after simplification is 7.1 into 10 power minus 6 grams. So nearly 7 micrograms is the answer. See, so simple. Step by step, what is needed? Go on coordinating. Arrive at the result. Next one, students. The half-life of SR90 is 28 years. Half-life of a radioactive element is given, which is 28 years. What is the disintegration rate of disintegration? ಏನಿದು disintegration rate andre? It is nothing but, again, activity of the sample. I have to find the activity of what mass of the sample? 15 milligram of this isotope. So, half-life of strontium is 28 years. What is the disintegration rate of 15 milligrams of this isotope? As usual, first convert half-life into seconds. So T half is 28 years. So this becomes 28 into 3.514. A very important conversion factor here. Always remember this. On conversion, 1 year is so many seconds. You need not spend time substituting, calculating. If you remember this parameter, 1 year is 3.154 into 10 power 7 seconds. Now, 90 grams of strontium again has 23 atoms. But I am finding the activity of what mass? 15 milligrams. So 15 into 10 power minus 3 grams constitutes what number of atoms? So on simplification, 15 into 10 power minus 3, 2, 3, 23 divided by 90. So when we simplify this, we have 1 into 20 atoms. Now, how do I proceed? I want rate of disintegration. Rate of disintegration, as I told, is nothing but activity. N is known. Lambda has to be calculated. Very good. Again, this is 0.693 by T half into the number of atoms. So when you simplify, we get 7.8 into 10 power 10 becquerel as the answer. So the activity of the sample is 7.8 into 10 power 10 becquerel. Next one. Obtain approximately the ratio of the nuclear radii of the gold isotope Au-197 and silver isotope Ag-107. I have been asked to calculate the ratio of the nuclear radii of gold and silver isotopes with mass number 197 and 107 respectively. Now, what is the expression for nuclei radius? We know R equals R naught A to the power 1 by 3. What is R naught? Constant. What did you call that constant as? Fermi's constant. So how much is A1 given to be? 197. Mass of the gold isotope, silver isotope 107. Now, I want R1 by R2 ratio of the nuclear radii. So this becomes A1 by A2 to the power, we told, nuclear radius is directly proportional to the cube root of the mass number. So, R1 by R2 is 197 cube root. So, when you simplify, this is 1.22, which is the answer. One mark question. feasible to appear in the exam. The next problem, the nucleus Ne2310 decays by beta emission. So very clearly the problem says a nucleus which is designated as Ne2310 is undergoing beta decay. Clearly, beta minus emission. Write down the beta decay equation. I have to write the beta decay equation and determine the maximum kinetic energy of the electrons emitted from the following data. Beta decay equation, and then calculate maximum kinetic energy of the electrons emitted in the process. Mass of the parent and the daughter nuclei is given. So, if I write the beta decay equation, Ne2310 is undergoing beta decay. The daughter nuclei formed is sodium. What are the conventions? Rule. Soddy's group displacement law for beta decay. Mass number remains the same. Beta minus ಆಗಿರೋದ್ರಿಂದ atomic number increases by 1 unit, plus electron is emitted and something called as anti-neutrino. So the first part of the problem is solved. I have written the beta decay equation. Now, ignoring the mass of the electron and anti-neutrino, if I calculate the mass defect here, so delta M is 2.994466 minus 2.989770. 2.989770, which is nearly 4.004696 AMU, or converting this into electron volts, 004696 into 931, which is 4.372 MeV. See, sodium being a massive element, if I ignore the energy carried by anti-neutrino, this will be the maximum kinetic energy carried by the daughter nuclei, which is the sodium. So with this, students, I complete discussion on nuclei. Next, I come up with the chapter Dual Nature of Matter and Radiations. Go through the sessions, prepare, and then attend the sessions on problems. Until then, have a nice time. Thank you.